Hello everyone, welcome back to the series where we are solving past 20 years of JEE Advanced question. This question was asked in JEE Advanced 2018 and it was multiple correct time. So we have to check all the options and see uh, what all can be what all can hold true. Okay. So it is given, consider a body of mass 1 kg at rest at origin at t equal to 0. Okay. So if we draw at t equal to 0, the particle was at origin. Okay, this is my xy plane, and force is given as alpha t I cap plus beta j cap. Okay, so in x direction force is a function of time, with time it is increasing. Okay, and in y direction force is constant. Okay, so in y direction acceleration will be constant. So this force is applied on the body where alpha is 1 Newton per second, beta is 1 Newton. Okay, the torque acting on the body about the origin at t equal to 1.1 second is tau. Okay, so this is given as at t equal to 1 second torque is given. Which of the following statements are true? Okay, so also it was at rest. So initially at t equal to 0 velocity was 0 in both the direction. So let's see what all will be the right options. Okay, so we have to calculate the torque. What is torque? Torque is nothing but r cross f. Okay, so we have to figure, we know the at t equal to 1 second we know the force. What will be the force? We have to calculate the position, right? R is the position vector. So let's see how we will calculate the position. So if again, as I always say, like, we have to make our life easy and we will consider the motion in x direction as independent of motion in y direction. Okay, here, so if let's see what we can do. Since it was in x direction, I am writing here in okay, I can write in x direction. What we will do, since it was at rest, so initial velocity in x direction is 0. Let's see what is force. Force in x direction is given as alpha t I cap. Okay, I am writing it here only. Okay, so if force x I cap plus 4, I can write force in two direction, which is given as fx I cap plus fy j cap, where fx indicates the force in x direction, is equals to alpha t I cap plus beta j cap. Okay, since mass is 1 kg, so if I divide it by mass, which is 1 kg, so acceleration is force by mass. Since mass is 1 kg, I can say acceleration will also remain same as force. Okay, so since mass is 1 kg. Okay, so fx I can write it as ax I cap plus ay j cap is alpha t I cap plus beta j cap, right? I hope everyone is fine with this. Now if on comparison we can say ax is nothing but alpha t, similarly ay is nothing but beta. Okay, value of alpha and beta both is given as 1. So ax is t, acceleration in x direction is function of time t, acceleration in y direction is constant, which is 1. So we have always dealt with the uniform acceleration, so we can simply say it will follow the equation of motion for uniform equation of motion for uniform acceleration. So sy, like displacement in y direction, is equals to uyt plus half ayt square, right? Similarly, we can say if we need velocity, vy is equals to uy plus at. Okay, so at t equal to 1 second, uy was 0. Why uy was 0? Because it was at rest, so there was no direction, no velocity. Ux was 0, similarly uy was also 0, right? So uy was 0, so it will turn out to be, and ay is 1, so half into 1 into t square, which is 1 by 2. So y coordinate sy will be 1 by 2 at t equal to 1 second. At t equal to 1 second, velocity will be u was 0, a is 1, so velocity will be 1 meter per second, or yeah, this is 1 meter per second, and distance will be 1 meter. So for y direction we are sorted. Let's see what will happen at x direction. At x direction, acceleration is not uniform, so we have to consider, we have to integrate it. So we can write ax as dvx by dt. Agree? Ax is nothing but dvx by dt. So if I bring dt here, so I can write dvx is equals to t dt. Okay. On integration on both side, what we can say, dvx is nothing but vx minus v naught. Okay, let me do it in proper way so that nobody will have confusion. Sorry. Okay. If I bring dvx is equals to t dt, now we can integrate it from initial velocity ux to vx, okay, where vx is velocity at any time t, ux is initial velocity at t equal to 0, and here we will integrate it from 0 to t dt. Okay, on integration we can write it as vx minus ux. What was ux? At t equal to 0, whatever the velocity was in x direction, which is 0 in our case. Integrating t square, this will give us t square by 2. So vx is, on putting ux is equals to 0, which was initial velocity, we will get vx as vx will be t square by 2. So velocity is varying like this. Similarly, we can also now with this we can write vx as dx by dt, right? Velocity in x direction is nothing but rate of change of displacement in x direction is equal to t square by 2, and again integrating it, we can write t square by 2 dt, integrating it from 0 to t and integrating it from 0 to x. At t equal to 0, x coordinate was 0, it was at origin. Okay, if I am not wrong, it was at origin, rest at origin. So we can write x is equals to t in, on integration we will get it t cube by 3, which is t cube by 6, because 2 is already there. So yeah, everything is with us. So now I can see that in x direction, velocity in x direction is given as t square by 2, and displacement, how x coordinate is varying with time, is t cube by 6. Okay, so now let's see what all is given. Torque at, we have to calculate torque at t equal to 1 second. At t equal to 1 second, x coordinate will be, at t equal to 1 second, x coordinate will be 1 by 6, and velocity will be, I am putting t equal to 1 by 2. So at t equal to 1 second, I am calculating torque here. At t equal to 1 second, my position vector is equal to x plus y xi cap plus yj cap, which is given as, at t equal to 1 second, coordinate was 1 by 6 and y coordinate was 1 by 2. 1 by 6 I cap plus 1 by 2 j cap, right? This is my R. What will be my force? My force will be, my force was given as, where is force? Alpha t plus beta j. Alpha and beta is 1, t is 1. So force is nothing but 1 I cap plus 1 j cap, right? So if we consider force, if we consider torque, which is nothing but r cross f, if we will do r cross f, 1 by 6 into 1 minus 1 into 1 by 2. Okay, so I hope everyone knows how does we do the cross product. Okay, I factor will get multiplied with j, and this is basically cross multiplication. So if we do r cross f, we will get 1 by 6 minus 1 by 2, which is nothing but what it will be, 2 by 6, right, which is 1 by 3. So mod will be 1 by 3. So I think option A is 1 by 3. Yeah, this is correct. The torque T in the direction of the unit vector, torque T is in the direction of unit vector plus k. So what will be the direction? Direction is not plus k. We got minus 1 by 3, right? This was minus 1 by 3. So if you see ij, direction of k is nothing but I cross j, and we were doing I cross j here, 1 by 6 into 1 minus 1 into 1 by 2. Okay, this was, I am highlighting here, 1 by 6 into 1 minus 1 by 2 into 1. So we got minus 1 by 3. So it was in the direction of minus k cap. So B is wrong. The velocity of body at t equal to 1 second is half I cap plus 1 j cap. It is 1 j cap, 2 into 1 by 2. So let's see, at t equal to 1, velocity in x was 1 by 2, which is correct, and velocity at y was 1, which is also correct too. So option C is correct. The magnitude of displacement of the body at t equal to 1 second is 1 by 6. Magnitude of the displacement. So magnitude of the displacement will be, if we know x coordinate, we know y coordinate. From the origin, the magnitude of displacement will be root of x square plus root of y square, right? X is 1 by 6, y was what was y? Y was 1 by 2. So it will definitely 1 by 6 square plus 1 by 2 square cannot be 1 by 6. So this is the x coordinate, but this is not displacement. This is displacement in x direction. So magnitude of displacement of body is not 1 by 6. Magnitude of displacement in x direction is 1 by 6, but total will be root of 1 by 6 square plus 1 by 2 whole square. So again, D is also wrong. A and C is the correct answer. I hope everyone understood the solution. This was pretty easy. We just did simple integration to figure out the velocities and the position coordinates. Thank you.